9 or 10D. So it doesn't really matter which one. Let's take a look at them both, and then I can decide. I think we did 10D this morning. So let's do 9D. Okay. And you're right, both 9D and 10D are a bit of a workout. I'm going to do the same thing I did with 10D this morning, which is to write 9D. Is this 9? Yep. Which is to rewrite this, just, nudging some of these pieces into slightly different positions. Strangely enough, although I am entirely deaf in one ear and have limited hearing in the other, there are certain noises that I hear as clear as a bell, and one is the clicking of a pen, if that's what that noise is. So I don't know who's doing it, but it's distracting, and I can tell it's stopped, so thank you. So all I'm doing here, Ashlyn, is I'm rewriting these just lined up a little bit neater. And instead of writing the cube root of 375 over 4, I'm writing 1/4 off on the side, because that quarter is a coefficient. And over today's work and tomorrow's work and the work on Friday, especially tomorrow and Friday, the concept of a coefficient, something that is not underneath the radical sign, becomes very important. Anyway, I'm going to also do the same thing I did this morning here. I'm not going to simplify cube root 81 right here. I'm just going to go to, I don't want to say scrap paper because you would have to show this on an exam, but off on the side, I'm going to figure out what the cube root of 81 is. We actually encountered 81 this morning, and I made a big deal out of it being 3 times 3 times 3 times 3. Because it's 9 times 9, and each of those 9s is 3, so it's 4 3s. Since it's a cube root, I can extract a group of 3 3s, there's 3 of them, and write a single one outside to get 3 times the cube root of 3. It's a veritable smorgasbord of 3s. Where am I? There we are. So this becomes 2/3, and then I have times 3 times the cube root of 3. Plus I have 1/4. Well, I'm not as intimately familiar with 375 as I am with 81, so I would have to do a little bit more thinking here with the 375. I think it's a cube root. I didn't even really look. Yep. 375. 375 is divisible by 25 15 times, I believe. Can somebody confirm that 15 times 25 is 375? It is. So from there, I can easily break this down because 5 times 5 is 25. So I have a 5 times a 5. 15 is 5 times 3. Oh, this is nice, because when I extract that group of 3 5s, I'm going to be left with cube root 3s, which will match the cube root 3s in likeness in the first term. So this is 5 cube root 3. What else do we have? We have root 99. I think many of us would just write 3 root 11. But, I'm not here for many of us. I'm here for all of us. Root 99. Well, 9 is a factor of 99. That's a perfect square. Again, I mentioned this morning. With square roots, I don't feel the need to write 3 times 3 times 11. I just write the factors where one of them is a perfect square. So that's 3 root 11. And we're so close to being done here. It's minus 4 times 3 root 11. And then plus 5 root 11. I could probably just get to the answer here in one fell swoop, but I'm going to just go slowly. What happens over here, Ashlyn, is this 3 cancels with that 3. And I'm going to be doing a lot of what I'm about to do in today's lesson and tomorrow's lesson and in Friday's lesson, which is to continually say to you that we can work with these 2 things because they're both coefficients. Okay. So I'm left with 2 times the cube root of 3 plus 5/4. There's no need for us to write 1/4 times 5. We can multiply across the top and across the bottom. Again, why can we do that? Because this is a coefficient. And that's a coefficient. You can play around with coefficients and coefficients. You can play around with radicals and radicals, but you can't mix and match. Cube root 3. And then we have minus 12 root 11 plus 5 root 11. So this last part is minus 7 root 11 because we have negative 12 of them and we're adding 5. Negative 12 plus 5 is negative 7. I suppose what we could do here is we could add these first 2 terms together using a common denominator. But I don't think it's necessary. 5 divided by 4 is 1.25. 1.25 plus 2 is 3.25. So we're adding 2 root 3's, cube root 3's, plus 1.25 cube root 3's. We get 3.25 cube root 3's, which I've kind of led you to believe, and it's I guess, basically true. Since this is a nice decimal, it's not some awkward 1,000,000 decimals to it, I can get away with that. But we would probably not see that on an exam. You'd probably see 13/4, I believe. Is that okay, Ashlyn? Perfect. All right, let's get started here on the next lesson. So we are looking in your unit handout, probably page 3. Yeah, at page 3. And this section is section 5.2. 5.2 in your textbook covers multiplying radical expressions and dividing radical expressions. You'll notice this has a Roman numeral 1 at the end of the title. It's part 1. Tomorrow we'll do part 2. The day after we'll do part 3. So there's a lot in here. What are we doing today? We're just multiplying. We're multiplying expressions that have radicals in them. Tomorrow we'll divide. Friday we'll divide more complicated things. It really boils down to a simple rule. And, you know, I don't like teaching math and saying it's all about rules. I want you to understand why the rules work. But at some point in math, you have to get past concrete math and get into abstract math. What do I mean by that? Okay, well, when I say what's 3 times 7, there was a point in your life where you had to get a bowl of Smarties to help figure that out. And I don't mean just to eat while you were thinking. Where you would make a pile of 7 Smarties and a second pile of 7 Smarties and a third pile of 7 Smarties, and then you would count them. And that's what we call concrete math. You're actually doing the math with something physical. But you know 3 times 7 is 21, right? There are also many situations, and I'll give you one that you're familiar with, where concrete math, quite frankly, is more confusing than abstract math. And that's algebra tiles. You guys remember working with algebra tiles in grade 8 and 9? Did you find them helpful? I would say 95% of the students I've talked to over the years go, it just confused me. Just tell me how I can do the math. What are some rules that will help me get there? So The rule is simple. When you multiply expressions that have radicals in them, you're allowed to multiply coefficients by coefficients and radicals by radicals. There's a reason for that, and I will get to it in a second, but in the end, we don't have to relive that reason every time we do it. We don't have to go, why is that again? You just do it. For example, oh, and by the way, you can only multiply radicals if they have the same index. So if you have cube roots times cube roots, you can do this. If you have square roots times square roots, you can do it. But you cannot multiply cube roots by square roots. There's nothing you can do with them. It's like me asking you to multiply x times y. What do you get? xy. For example, if I say to you, we're going to multiply 5 times the cube root of 6 times 3 times the cube root of 7. So I'm multiplying this thing and this thing. I can show you that there's two what we call coefficients. A coefficient in this case is a number that you're multiplying something by. So you're multiplying 5 by the cube root of 6, and you're multiplying 3 by the cube root of 7. Those are coefficients in those two terms. Those are radicands in those two terms. So 5 is a coefficient, 6 is a radicand, 3 is a coefficient, 7 is a radicand. By the way, I don't know that you remember this, but we might as well talk about language here. If I have root 7 is called a radical. But 7 is a radicand. So the radicand is the number under the square root sign. I can't remember if I mentioned that explicitly before or not, but I'm doing so now. Okay, that's the index. So they have the same index, we can multiply them. So what do we get? Well, 15 root 42, because 5 times 3 is 15. The coefficients multiplied together, I want to make this very clear, the coefficients multiplied together give you the coefficient of your answer. The radicands multiplied together give you the radicand in the answer. And I've got a question mark here. Well, let's grab our calculator and let's find out if this is true. I wish the Texas Instruments family of calculators just had a cube root button somewhere, but you have to go into the math menu to find it. So if I want 5 times the cube root of 6, I need to go into the math menu and choose option 4. It looks kind of wrong. It looks like that says 5 cubed, right? At least to me. That's not what it means. It's the cube root. By the way, if you have a TI-84, does it basically look like that as well? If you have one of those real fancy ones with the color screen, is it a little bit better? It's a little bit better. Maybe the 3 is a little bit smaller. Or it's tucked in a little closer or something. It's a little higher up. Okay. So that's times cube root of 6. Close the brackets on that cube root. That 6 is the argument of the cube root. You want to close it because you only want to take the cube root of that. Times 3 times the cube root of 7. Since that's the last entry, we don't have to close the brackets, but I'm going to, and we get 52.14. So what is 15 times the cube root of 42? We get 52.14. I mean, that's not a proof, but it's good enough for here. I mean, we're getting the same thing. Oh, look at that. I got it right here for you. So it works. That's the rule we're going to use. So example 1, multiply. This statement here, everybody, is something that I will not always tell you to do. In math at this level, when you get an answer, it must be simplified. Always. You get 15 over 30, you have to write 1/2. So what do we have? Well, it's written a little bit differently, but basically we have 2 root 5 multiplied by 5 root 6. So we're going to multiply the two coefficients to get a new coefficient. We're going to multiply the two radicands to get a new radicand. So 2 times 5 is 10, root 30. Now, can you simplify that? So the question is, can you simplify root 30? No, because 30 is 6 times 5. That's it. No perfect squares, no pairs of numbers that are identical. Why does this work, by the way? Well, if I ask you, and this is the why that I'm going to explain once, and I'm not going to worry about explaining it every time. If I say to you that my favorite triple of numbers to explain this is 2 times 3 times 4, I would like you to calculate 2 times 3 times 4. I mean, I know you rely on calculators, but it should be able to do it without it. It's 24, isn't it? How many of you did this without a calculator and you said basically 2 times 3 is 6 and then 6 times 4 is 24? Okay. If I say to you, what is 2 times 4 times 3? Is that also 24? How many of you, maybe the same people, said 2 times 4 is 8 and 8 times 3 is 24? You tend to do the first two numbers first. But my point here is, it doesn't matter the order in which you multiply. You could say this is 12, 12 times 2 is 24. This is 6, 6 times 4 is 24. This is 8, 8 times 3 is 24. So when you look at this, what does 2 root 5 mean? It means 2 times root 5. What does 5 root 6 mean? It means 5 times root 6. So you're multiplying 4 things together. You can multiply them in any order you want. So I can write this as 2 times 5 times root 5 times root 6. You learned, I don't know when you learned, grade 2, 3, that 2 times 5 is 10. I don't know where you learned it formally, but at some point you figured it out. You learned in grade 10 that we are allowed to do this. So we multiply the coefficients, you multiply the radicals, which involves multiplying the radicands. Let's try number 2, negative 8 root 15 times 3 root 10. So we can multiply. I don't think there's any need to rewrite this. I mean, you can rewrite it if you want. I'm just going to make it bigger. We're going to multiply these two things together because they are both coefficients. We're going to multiply these two things together because they're both radicands. And we will have our answer. Right? So negative 8 times 3 is negative 24. 15 times 10 is 150. So we have negative 24 root 150. Any questions with that example? Sasha? You have to simplify root 150. Now before we break down 150, I want to just maybe give you a tip here that might be helpful for some of you. Is there a factor in 15 that is also a factor in 10? There is, isn't there? That means when you put them together, you're going to have that factor appearing twice, so it's simplifiable. And that factor is 5, isn't it? So that might be a tip to you that we're going to have a factor of 5 and a factor of 5 in the product of 150, and you can figure out what the other number is. So root 150 is 20, root 150 is root 25 times root 6, which is 5 root 6. So Sasha is right. We have to always simplify. And you're going to see this a lot more tomorrow. Well, let me finish the question. Negative 24 times 6 root 150, times 6 root 6 What am I doing? Times 5 root 6. There we go. The root 150 is 5 root 6. You're going to see this more and more tomorrow, and it's almost like you feel sometimes, is it ever going to end? Or you do something you're supposed to do, and you create in the process something else you need to do. We multiplied the coefficients to get negative 24. We changed the root 150 to 5 root 6, but now what we have created are two more coefficients that can be multiplied together. So it's almost like you have a checklist at the end. Are all of your coefficients taken care of? Are all of your radicals taken care of? Are your radicals simplified? So now we can multiply negative 24 and 5, which gives me negative 120. Thank you. Negative 120 root 6. Any questions with that second one? Okay. 2x root 5x to the 5 times 4 root 75x cubed. I do want to rewrite this one. Again, I mean, I certainly don't need to do this every time, and sooner or later I'm going to stop doing it, but those are two things we can multiply because they're both radicands, whereas these are two things we can multiply together because they are both coefficients. 2x times 4, the yellows give 8x, and then to get the new radical, the radicand will be the product of 5 times 75, which is 375. X to the 5 times x cubed, which is x to the 8. And now what we have to do, and again, this is just my preference. I prefer to work out what 375 x to the 8 under a square root is on the side. I don't want it inside of all my work. Then I have to rewrite whole lines with every bit of work. So 375, well, I already know 25 goes into it. I know 25 goes into it because it ends in 75. But can you confirm 25 divides into it? 15 times, I believe. So we can rewrite that part. I'm just going to put it all together as 25 times 15, and then we have x to the 8. So that root 25 comes out, and I have 5 root 15 x to the 8. Well, what am I going to do with the x to the 8? Yeah, I'm going to take the whole thing out. But what am I going to write it as on the outside? See, this is where I think many of us have to go back to the beginning. I'm going to see if I can get them all in here. And think of or write the 8x's multiplied together. And each pair comes out. That comes out. That will come out. That will come out. And that will come out. But each of those, when they come out, will be x to the 1. So I'm taking out an x times an x times an x times an x. I'm going to get x to the 4. So now we have 8x. And then outside of this radical, we have the 5. We have an x to the 4. And then we have the square root of whatever's left, which is 15. We get a coefficient times a coefficient. So we can multiply those together. 8 times the 5 in these coefficients is 40. X to the 1 times x to the 4 is x to the 5, root 15. I sometimes forget to do something, and I shouldn't, but we do have to talk about non-permissible values. And I don't know if I've talked about this with you yet, because I'm mixing up in my head what we've done already with what we're doing tomorrow and Friday, because I'm not here tomorrow and Friday, so I've recorded those lessons already. So I've already taught the next 2 lessons, and I'm thinking that I've taught you something in the future, is what I'm thinking. It's important when you talk about non-permissible values that you talk about of the original expression. So the fact that in question C, we end up with an answer. This is our answer. We end up with an answer where there's no variable under the square root sign, doesn't change the fact that there was. And we talked about this yesterday. If you have x to the 5, if x is negative, then x to the 5 will be negative, and you're taking the square root of a negative, and that's not allowed. So what this means is that x must be greater than or equal to 0. Now, while we are here, as I said, I recorded the lessons for the next couple of days already. I want to show you a mistake I made, and it may have been a mistake that I made in one or both of the lessons, but I just want to show it to you. It's something that you would never think of, but let me show it to you. Not there. Right here. This is a question from tomorrow, so don't worry about what the math is because you don't know how to do it yet. All this stuff that's written below we'll talk about tomorrow. But I want you to focus on this statement. And I want you to look at this expression. Does it make sense to you that I am saying r must be greater than or equal to 0? Can somebody explain why r must be greater than or equal to 0? And then I will tell you why we're wrong in saying that. Okay, I don't mean to confuse you, but Jack, what's on your mind? What do you want to say here?
Well, if you were to times a number that was smaller than 0, by itself, 5 or 3 times, then that resulting number would still be negative, and you cannot get the square root of a negative number.
Perfect. And I'm just going to repeat that in case the mic didn't pick it up. If I put in a negative number for r on the top, and I take negative 12 raised to the 5, that means I'm going to take negative 12 and multiply by itself 5 times. And I'm going to get a negative number. I don't know what it's going to be, but it's going to be negative. And it's under the square root sign, and I cannot take the square root of a negative. And the same could be applied to the bottom. But does anybody know, and I don't know if any of you were going to get this, but why is this thing that I'm going to unhighlight for a second, why is this thing right here wrong? There's something that I should have, and as a math teacher, I know this. I don't know why it slipped my mind. Do you know, Lucas?
Because you're dividing r by r. And if it's a negative, cancel out.
Yes and no, but that's actually not it, because remember what I told you, you have to go with the original expressions. So imagine that you divided and the r's went away. It still doesn't matter. There's something about that statement I'm pointing to which is kind of right, but it's not right.
Well, if you had like just plain r to the fifth divided by r to the third, it would be something like r to the second, right?
Yeah.
So is it some? Does that work?
I think you and Lucas are saying the same thing. And what I'm saying is we don't want to look at it simplified. We can't simplify it and then say, oh, since it's going to be r squared, r can be negative. It doesn't work that way. It has to be with the original expression, which is a very important idea for next year. Non-permissible values are determined by looking at the original expression. I don't know if anybody's going to get this. This is what it should be. Because you're dividing by something that has r in it, and you can't divide by 0. So, for example, just to summarize this, and then we'll get back to today's lesson, if I gave you the following expression, and I said, what are the non-permissible values? And then I gave you this expression, and I said, what are the non-permissible values, or what are the permissible values? X must be greater than or equal to 0 here. X must be greater than 0 here. Because if X is 0, you're dividing by 0. And it's such a subtle difference, and after I finished recording it, I thought I would try to edit in. So it was apparently tomorrow's lesson where this happens. And it won't be the only place tomorrow. When you're watching tomorrow's lesson here, here's one. Someplace along the way, I'm going to say, oh, and by the way, r must be greater than or equal to 0. No, since r is in the bottom, r must be greater than 0. So there's an error in the video. And I'll probably put the error in the description when I upload it. Anyway, let's get back on track here. Where were we? Multiplying. Oh, we were done that. Is that right? We finished this one? Oh, yeah. There's the answer. All right, let's take a look at the next one. Well, I'm a big fan of saying to you, a student, if you don't understand what you need to do, ask yourself what you would do if it were simpler. And I don't mean 1 plus 2 simpler. If it were similar but simpler. All this is a monomial multiplied by a binomial. And when you have a monomial multiplied by a binomial, you multiply the monomial by each part of the binomial. So we are going to multiply 7 root 8 times 6 root 5 to get 42 root 40. And I want everybody to just take a breath and think about where I got 42 root 40 from. The 42 is the 7 by the 6 multiplied by the 6. The root 40 is root 8 times root 5. And then I'm going to multiply the 7 root 8. So I've done this. Now I need to do this. 7 root 8 times 9 root 20 is 63 root 160. Is my multiplication correct? Okay. Are we done? Well, no. Root 40 can be simplified. And again, I prefer to show my work on the side. Root 40 is root 4 root 10, which is 2 root 10. So I have 42 times 2 root 10 plus, oh, this is going to be very nice. because I think we're going to get root 10s out of the root 160 as well. Root 160 is root 16 root 10, which is 4 root 10. Again, you know, if you chose to do this work in here on the left, you can. I just like doing it off on the side. So we have 63 times 4 root 10. What do we get? 2, see, we're back to this thing again. Coefficient by coefficient. Coefficient. That's a 4, right? Pretty sloppy of me. Coefficient times coefficient. So what can we do here? 2 times 42 is 84 root 10. 63 times 4 is 252. And now we're back to what we learned yesterday, which is that you're adding things that have the same radicals. We call them like terms. So I need to take 84 kittens plus 252 kittens, figuratively speaking. They're not kittens, they're root 10s. And I get 336. 336 root 10. Any questions with that one? Yeah.
Would you be able to simplify like what's in the brackets and then add them together and just multiply the two?
Certainly. And this, I'm glad you asked, because if nobody did, I would say, and we could do it a different way. You will discover that when you watch tomorrow's lesson, I am a huge fan in tomorrow's work of simplifying any radicals before you do any multiplication or any other bit of business. And what you've done is you've started saying, if I simplify them to begin with, I could have added them together. And I will show everybody else what you and I are talking about in a second, but your way is going to get to the answer quicker, isn't it? But it won't always. And this is the weird thing about radicals, is that you may choose one path one day on a particular question, and then the same path on a different question on a different day, and for some reason it just takes you a lot longer. But generally speaking, everybody, this is a general idea. I like to simplify the radicals first. So for example, root 8 is 2 root 2. I mean, I don't know how many times I'm going to have to do this or how many times I will do this before I finally say, oh, come on, we know that root 8 is 2 root 2. So I can simplify that. I have times 6 root 5. Root 5 is non-simplifiable. Plus 9 root 20. Root 20 is 2 root 5. Let's see, root 20 is root 4 root 5, which is 2 root 5. Bless you. So I get 14 root 2. And here, I don't want to rewrite the whole line. This is 18 root 5. 9 times 2 is 18. 18 root 5 plus 6 root 5 is 24 root 5. You're starting to get into an area here where I say very often to my math students, it's one of the things I like about math is as long as you follow the rules, you will get to the right answer eventually. You know, if you don't get the right answer, it's because you don't understand the math. As long as you're doing the math properly, different paths will get you in the same place. Root 2 times root 5 is root 10. What is 14 times 24? Well, it better give you that, I don't know what it was, 353? I don't remember. What's 14 times 24? Will? 336? Is that what we got over here? I better be. Yeah, 336. This is the thing I like about math. It doesn't lie. It's not like, well, what do you think? It doesn't matter what I think. Let's see what the math says happens. Absolutely, Ashlyn. Let's take a look at another one. Well, we're going to have to FOIL. Look, just because it looks complicated doesn't mean you can't do it. You know how to FOIL. You know that when you have A plus B times C plus D, you multiply these two. You multiply these two. First outer. You multiply these two. This is an O, not a 0. You multiply these two. You multiply these two. There's a rule and it works. So we're going to do that. But look, when I multiply first, everybody, I am not going to write 8 root 2 times 9 root 5. I'm not going to write that. I'm going to say 8 times 9 is 72. Root 2 times root 5 is root 10. That's my first. My outer. Well, what's my outer? 8 root 2 times 6 root 10. By the way, Ashlyn, there's nothing here that we can simplify to begin with. So we're stuck with it. My outer, now I am looking at this times this, is 6 times 8, which is 48. Root 2 times 10, which is root 20. My inner, now I'm looking at multiplying here, these two. There's no radical in 5. So what do I do? Well, I multiply coefficients with coefficients. Negative 5 times 9 is negative 49, and we're multiplying it by root 5. Just because there's no radical in one of the terms doesn't mean you can't still multiply the coefficients. And then my last, we're going to multiply these two. Negative 5 times 6 root 10 is negative 30 root 10. You double check my first, outer, inner, last. Obviously, I just saw a bunch of hands go up. What did I write? Go ahead, Miles. You know, I do know that. I do know that 5 times 9 is 45. I hope I said 45. I don't remember. But you're right. Thank you. I always like to throw those in to keep you on your toes. It's 45. Does it look okay now? Okay. We have a couple of like terms. We have this term, which is like this one. They both have root 10s. But before I deal with that, why don't we just play around with this 48 root 20. 48 root 20 is 48 root 4 root 5. Do you see what my motivation is for doing that? My next term after that is root 5s as well. So what do we get? We get 48 times 2 root 5, or 96 root 5. So what do we get? 72 root 10 minus 30 root 10 is 42 root 10. How's my subtraction skill? Good, thank you, Jack. And then I have 96 root 5 minus 45 root 5. Ooh, 51 root 5. Done. Whoop. Done. You can't simplify root 10, so we're done over here. You can't simplify root 5, so that part is done. You cannot combine those two terms because they're not like each other because they have different radicals. Any questions with that one? Cube root of 4d to the 5 times cube root of 16d to the 5. Now, could we simplify each of these first? Yes. Could we multiply them first? Sure. I'm going to choose to simplify them first. the cube root of 4 d to the 5. And I hope every time I do this, more and more of you are saying, I don't need to write out all the d's. Has a triplet, or sorry, it's a cube root. Man, oh man. Cube root. Has a triplet of d's that I can remove. So it's going to be a single d on the outside times the cube root of 4 times d squared. And then we're going to multiply that by, well, let's do the same thing with the second term. We're going to multiply that by the cube root of 16, which is 2 times 2 times 2 times 2 times d to the 5. Well, we've already done that. I'm not going to do it again. I can take 3 of those d's out and have a single one outside, leaving me with d squared inside. I can remove a triplet of 2's and write it as a single 2 outside, leaving me with that. So I'm going to multiply d cube root 4d squared by 2d cube root 2d squared. Here's why I'm not in a case like this, and you'll get more experience. Yeah.
Instead of 16, I have 600.
You have a different number on yours? What number do you have?
600 or 160.
Change it to 16. So rub out that 0. Not sure what happened there. I think it's easier for you to rub out the 0 than for me to start again. You will get more experience with this, but here's why I wouldn't have done this first. I would have multiplied. All this work on the side that I did to get here, let's multiply this out and see where that leaves us. It leaves us at 2d squared, d times 2d, the coefficient times the coefficient is that. And then we have the cube root of whatever this times this is, which will be 8d to the 4. All that work I did on the side, I got to do it again now, right? I now have another radical, and I have to repeat the process. Now, you're not always going to avoid that, but looking ahead, I knew that those d's would pile up by multiplying, so I would have just multiplied them first and then taken out what I could in one shot. So what is the cube root? What is this equal to? It's equal to the cube root of 2 times 2 times 2, that's the 8, times d times d times d times d. I can take out the 3 2's. I can take out 3 of the 4 d's, leaving me with 2d squared, which I had. I removed another 2, and I removed another d, and then I have the cube root of whatever's left over, which is just a d. So I end up with 4d cubed, cube root d. I would say to you that the work we're doing here is not difficult. There's just a lot of it, right? A lot of little basic parts. And to really drive that point home, let's take a look at the final example. This time you have a binomial multiplied by a trinomial. I'm just going to rewrite this. 5 root 14 minus 3 times 4 root 7 plus 2 root 6 plus 5. I think you're in for a pleasant surprise here once we multiply this out. Whenever you have well, if you go binomial times binomial, the reason why FOIL works, and I think I have one here where we had FOIL. The reason why this works, just focus in the top right corner of your screen, is that FOIL ensures that everybody in the blue group dances once with everybody in the yellow group. That's what's going on. That's what the distributive property of multiplication means. Everybody in one of the polynomials gets multiplied by everybody in the other polynomial. So what that means in this case here, everybody, is you need to multiply these two, these two, these two, these two, these two, and these two. We have to multiply everything in the second polynomial by 5 root 14, and everybody in the second by negative 3. And it's a matter of being organized here. 5 root 14 times 4 root 7 gives me 20 root, I just might need a confirmation here, 84, 14 times 7. Okay. And then 5 root 14 times 2 root 6. So I'm working systematically. I'm going 5 root 14 times this one, then times this one, then times this one. 5 root 14 times 2 root 6. 5 times 2 is 10. Root 14 times root 6 is root 84? No. 98. And then 5 root 14 times 5 is 25 root 14. Yep. Is the first one 98 as well?
No, I meant the first one was 98, not the second one.
Okay.
Second one.
Really? So this one's 98, that one's 84? Wow, did some wires ever get crossed in my brain? Because I said 84 and then I thought this one was 84. This one was 84. So is that right now, Lucas? Okay. Now, what I like to do here, everybody, is I just like to go check. I'm done with the 5 root 14. I move on to the negative 3. Negative 3 times 4 root 7 is negative 12 root 7. Negative 3 times 2 root 6 is negative 6 root 6. And negative 3 times 5 is negative 15. And by the way, it's not an excuse, but I make mistakes like that because I don't grab the calculator automatically. And I know that there are good students that do the math in their head and they make mistakes as well. Sometimes mistakes as simple as, 5 times 8, and then they write down 30 for some reason. But they know different. So be careful with that. Am I done here? I can simplify root 98. Root 98 is root 49 root 2. Which is 7 root 2. I'm going to ask this question, even though we've only been working on this for a couple of days. How many of you go from root 98 directly to 7 root 2 now? Okay, as long as you're confident and you don't make mistakes, then that's fine. 84. 84 divided by 2 is 42. Well, 4 goes into that, doesn't it? This is 10 root 4 root 21, I think, which gives us 10 times 2 root 21. There's nothing we can do with 25 root 14. There's nothing we can do with minus 12 root 7. There's nothing we can do with minus 6 root 6. And there's nothing we can do with 15. So we're just about done. 7 times 20 is 140. We get 140 root 2 plus 2 times 10 is 20. We get 20 root 21 plus 25 root 14 minus 12 root 7 minus 6 root 6 minus 15. So the thing about this one is it says simplify. And I know that you would look at that and go, how on earth is that simpler than what we start off with? And I agree with you. I don't think it's any simpler. But the surprise, the pleasant surprise here is none of those terms can be added together. So we're done. We have 6 different like terms. We've got 15s, root 6s, root 7s, root 14s, root 21s, and root 2s. So that's it for today. Page 289, 1 to 5. I'll tell you right now that tomorrow's lesson is about a 30-minute video that you'll be watching and then practicing and helping each other out with. And the one on Friday isn't much longer either. I just find that when I'm recording a lesson, there's not really any interaction, so there's no point in dragging it out. Okay? Get to work on that. I need to take attendance and take care of a couple of quick things, and then I will be around to help you out.